We've seen that if we assign an object to a name at the global level, and then reassign a different object to the same name at the local level of a function, the assignment inside the function doesn't stick when we exit the function. Let's demonstrate. We set a equal to 7, printed out that value, entered my function, changed a to 12, printed out the value to make sure it was there, exited my function and returned to the module level, and we find the reassignment of a to 12 didn't stick. A is back to 7 at the module level. But what if our intention was actually to alter a in the global namespace? And there are some things that you just can't do. Like suppose we want to increment a inside my function. We'd like a to equal a plus 1. Remember that Python looks through our function to see that we are planning to create a local variable name a, so Python removes the global a from the namespace of my function. It's no longer accessible. So if we try to say a equals a plus 1, the original a equals 7 is just not valid here, so we'll get an error. We can fix this by using the global keyword. We use the global keyword at the beginning of a function to indicate that we want that global a to remain in the namespace of my function, even though we're doing an assignment inside my function. So once we use this keyword global and run the code again, nothing changed in the first two lines. We set a equal to 7 at the module level, printed out the value of a, called my function, set a to 12, printed out the value correctly. After exiting my function and back to the module level, we see that the assignment of 12 to a sticks. And the reason is that the scope of a didn't change when we entered my function because we defined it as a global variable. If you've coded in other languages, you may have seen that we define global variables at the module level, and then they're global forever. But in Python, it's actually the innermost function that has control over how the namespace is defined. And now, since we've defined a as global, we could increment it here. A equals a plus 1 will work because the a on the right-hand side of the assignment operator is defined. Let's make this 12 again, and then explore some other unexpected consequences. We'll define a nested function, put the global statement inside the nested function, reassign a, and remove the global statement from myfunc. So now we've defined a at the module level, and again in myfunc, and again potentially in my nested func. Let's run this and see what happens. If you follow this code carefully, we call myfunc and reassign 12 to a. But in fact, we're not reassigning. We're creating a brand new variable name because we haven't used the global keyword inside myfunc. So when we print out the value of a in myfunc, it's 12. Now we make a call to the nested function, declare a as global, reassign 13 to a, and remember we've now grabbed that a from the global namespace. So we're truly reassigning a at the global namespace. And the value is 13. But after exiting my nested func and continuing to the next line of code, we find that the variable name a inside of myfunc still refers to the integer object 12. This variable name a is local to myfunc. This variable name a was defined as a global, so it refers back to the name that we created at the module level. In fact, when we now return out of myfunc and back to the module level, notice that the change we made in the nested function actually sticks. Now to go one level deeper, there's another keyword called non-local. If we change global to non-local, then Python is going to bind this variable name a to the nearest enclosing namespace where it can find a definition of that name. In this case, it jumps up to its parent function, myfunction, and sees that a was actually defined there. So now these two names a have the same scope. Let's run this program again. Because I defined the name a as non-local in my nested function, I'm not creating a new name, but I'm referring to the name that was created in the nearest enclosing function. So now when I make a change to a inside my nested function, here, the change is felt inside of my function. But I didn't use the global keyword, so the change was not felt at the module level. This kind of binding and mapping from names to objects is subtle and confusing. Play around with your own examples, rewind and play the video again, and make sure you really have a good handle on how these namespaces work.